Hey guys, welcome back. This is episode 9 and the last one of this LEGO build series. We're doing the Volvo Wheel Loader, and this episode's all about assembly. So if you've followed along the other episodes, we've modeled all of the parts. I think there was 26 parts. For ones that we maybe skipped over during the process, you can follow the links in the description below, sign up, and you can download the files, either SolidWorks 2023 or step files. Once you've got them, then you can follow the assembly tutorial as I've done here. During the assembly, we do some checks as we're going. We see some interference. We do some editing both in the assembly and in the separate parts to make sure that we kind of remove as much of that interference as possible. Please let me know how you found it, if you had any troubles, or if the links worked when you've downloaded them, and let me know what model you might want to see me do next. Front plane hidden and the top plane hidden. We're going to use the right plane for reference for our mirror. Also, as I want to get the orientation right, one of the first things I'm going to do is set the isometric view. So I'll just spacebar to get my orientation. I'll go isometric and I'll go front. So I can see this is the front view that I want to finish with. This is the isometric view. Here's my first part. Let's get this in a position that's fully defined, and then we'll start building the next parts in a correct orientation so that the green one is pointing towards the back. So we have to flip it around. All right, so first part, that's here, lift arm. Now I'm just going to drag that to the top of the assembly as well. We're not going to be too specific about putting these in step by step or anything like that. We'll group some parts later, but I just want to get the first one at the top of the tree. So this first one, it's actually the top plane that is running through the middle of the part, and we're going to use that to mate with the right plane. Now later, we will change its location as far as height. Once we put the wheels on, we'll lift up the wheels so the wheels are sitting on the top plane. But to start, we'll start with this just matching front plane to top plane so that it's aligned. And then the last one is going to be the right plane and the front plane, right? So that part with those three mates, you can see here, 1, 2, 3, that part's fully defined. Now, the bottom of my assembly says fully defined, my assembly file, but I don't think that's right. It was only 3 mates. That's a bit weird. I'm going to save this as, because I don't want to oversave the assembly ready file. I'm going to change this as work in progress. Okay, so that one's fully defined. Now we need to do those 3 blue parts. And so instead of being 2 and 1, we're going to have 1 and 2. So the green one ends up facing the other direction. So those blue parts are here. Now we're going to press the mate tool, select the face. This is going to be a concentric mate. Very straightforward. We're also going to hit lock rotation. That's going to save us from having to do another mate with planes to stop that from turning around. So it can still move in and out until we do the next mate, but it won't rotate. And the next mate I'll do is this face here to this face. And that's what puts it in the correct position. I'm going to press OK. Just have a look at our assembly. So we're going to have 1 on this end and 2 on the other end. Now I've got this part here, one of these parts already. Just going to move that to the top of the assembly. I don't know why it doesn't want to let me change its position in the feature tree. Very strange. Let me just close and open again. Hello, Hetz. Thanks for joining. Hetz, what version of SolidWorks do you have? Because if you have a newer version, you can download the files and follow along with the assembly. I think there is a Google Drive link that has all the files available. I can share that actually in the chat, I believe. 2025, yep. See if that works. All right, so I'm going to do the next part. I'm going to grab a duplicate of this one. So I'm going to press Control on my keyboard and click and drag, and I get 2 copies just like that. And then I'm going to do the same thing that I did with the first one. So concentric mate, lock rotation. Let me know how you go with that, Het, if you're able to open and play around. The file that you should open is in the SolidWorks folder. Open the one that says assembly ready once you've downloaded your copy. Okay, so for these parts, I'm going to make these faces, and I can do a multi-mate. So a multi-mate lets me select this face here and select 2 other faces and get them all in line at the same time. Press OK, and that's done. All right, so that's my step 1. Okay, so step 2, we're getting one of those black L shapes, but we're going to remember we're reversing. So what we're doing on this is reversing from the instructions here because we want the finished product, the bucket, to be facing the front, our front plane. So we have to just flick reverse the instructions while we're looking at them here. So my next part, the black one, just put it on the other end. So let's come across here. I've got the part, drag that across, and I'm going to set, so the L shape goes in the middle. I think this hole and this part align. I'm going to flip the direction, and then I'm going to select those two faces to keep them parallel. And then these are going to be coincident, basically in contact, because they are both 8 millimeters, I believe. 7.8. Or should there be a little gap? I think there should be a little gap. I think I may have did this wrong in my first assembly. So I'm going to put a gap in here of 0.2. Well, you will check for interference and things later. So we've flipped that one around. We can see it's got that little grey part that goes in there as well. So we're going to put one of those in. That's here. And that is going into that bottom corner hole with the long end going in first. It is all solid modeling, not any sort of surfacing. That is correct. No surfacing at all in this project so far. There won't be any surfacing. We've finished making all the models, all the parts. So now we are just doing the assembly and then some refinements to those models. All right, there is that part is in. Right, next step, we get a longer grey one, another blue, a tan piece, and an orange piece. So we're getting another one of these greys. I'm just going to duplicate that. I'm going to get another one of the blue ones. You get one of these tan ones, and then this orange piece over here. All right, so the assembly, the grey one's going to match these holes, and it's going to match this face. So it has a little gap. The tan piece sits in the middle, like that. We'll just go back to make that lock rotation. Not that one, this one. And then we're going to select this face to get those combined. It also has a blue one on the end. So here, flip that, lock rotation, and get that face matching that one. So we've got those three, and then the orange one on the outside. So this orange one, I'm going to select this face and this face to be coincident. Now we're going to do here a width mate, because this orange piece, you can just have a look at it. It doesn't have any, it's got a round detail here. We might be able to use that actually to line it up. I'll show you the width mate anyway. The idea with the width mate is it helps you find a middle of two parts if you don't want to select a plane. So I can select this face, this face, this face, this face, and go and press mate, and it's going to automatically choose a width mate here, centered, to get those two parts aligned. The alternative, because it does have that cut in it, if I can just see up here, this one, I can align that hole with this one. That's going to be concentric. And then I can press this face and this face to make them parallel. That should work as well. We'll have to check later. And it looks like maybe it sits a little bit low and see here. So we might have to tweak it. We'll see if there's any interference. That is step 3 done. Now we're up to step 4. And remember, we're doing this backwards, so that green is going the other direction. So it's got a green L shape with 3 of those blue pieces. Now we're going to grab, I think there's only one green throughout the whole assembly. We're just going to grab that one, 3 of the blues. We're going to rotate it around. So I like to rotate these sometimes freehand before I make them. It just makes things a bit easier. By using the mate tool, I'm going to grab all these concentric mates. Lock rotation. So we've got 2 in the end and 1 in the bottom. I'm going to get them in the right position. Multi-mate. Okay. And then if I look at how it joins, it's got the top one going through that black piece. So I'm going to line up these two. Move it across. Also going to line up this hole. And then I'm going to get this part to be in the middle. So I'm going to grab the top plane of that part and the right plane of the assembly and hit mate. And that moves them together. So that'll be fully defined now, those parts at least. All right, we are step 4 done. Step 5, now we've got a little sub-assembly here. We're not going to make any sub-assemblies, at least I don't think we will. Yeah, we're just going to use all the mate tools available to us here. I'm going to grab a couple of these parts and a couple of the short grey ones. Now I'm getting duplicates of these just because I know I use more of those later. So you can see what we're doing here. Hello, Awasmi. Thank you. Yes, it's pretty cool. If you have SolidWorks, You can join in the fun by following the link in the chat or in the description below to get to Discord. At that link in the Google Drive, you can find SolidWorks files and step files if you're not using SolidWorks. You need to use SolidWorks 2023 and above. If you've got older version of SolidWorks, you can use the step files. There's a little bit more work, but it works. Okay, so let's do the next part. So we've got this sort of little sub-assembly to do. So I'm just going to line up a large and a small of the yellow pieces and then those axle pieces. Now the large one's on the outside. So there's a few ways we can do this kind of mate. I'm just going to do concentric. Now I'm going to do a coincident. Okay. Now these axle parts that we did, they're rounded on the outside. So I can select that round face and this round face. And then I'm going to find the right location, but then I have to align them. So I have to select this face and this face to get it to align the right way. And then file leave the end face to get it fully in the right position. So there's one that goes through the bottom hole, one that goes through this upper hole. So similar thing, we want to get these faces aligned, and this one aligned as well. With that all done, I can then put it in position. So we are mirroring this backwards just because we want a certain facing for our front view later. This one goes above that end grade point. So I'm going to grab my mate tool. I'm going to get it's the middle hole, this one, and this blue one to mate. And then it should be that those two parts basically match the same width as this, and they'll be parallel. Okay, so they'll be lined up. You can see how that's working out. All right, next step. Yeah, the curved panel. Okay, so here they see that little rotate symbol next to the number 6. They rotate it around, so now it will match the current orientation we've got, although on the reverse side, that's fine. I grabbed that yellow panel. It was only one of those, so I'll just bring that over, and I'm going to use the rotate just to move it around quickly. And then I can see, like from this point of view here, that hole, and it's going to be this concentric. And then to make sure it's in the middle, I'm going to look at that part, find its right plane, and get that matched to the right plane of the assembly. Is it easier to make Lego assemblies in the brick or this Technic form? I don't know. It's a good question. There is another model that I've done before, which I may as well, I'll open it. I'm not sure if it's going to cause any issues, but this other one that I've done before does have more bricks and parts, a lot more bricks and a lot more parts, and they have their own complexity to them. So this is the off-road buggy, and the more complex parts in this one were things like some of these moldings, which are nothing really like your standard Lego bricks. Yes, they have some connecting points to them, but it's completely different geometry to like a normal 2x2 plate. This whole assembly this project started with a plate like this, 2x2. That's very straightforward. I made it in a complex manner that had a lot of configurations to it, right? So you could do all these different sizes. That's a bit complex, but yeah, I don't know how to describe it. There's complexity all around, different ways. Hard thing is that they're tricky to measure. They're very small. So the smaller the part, like these tires, the trickier they get. Let me close that. That file is, by the way, available as well from the same Google Drive. So let's keep going with this one. We also have to align this hole here, so that gets fully defined. All right, looking good. Now we check against our instructions. Yeah, thanks, OSME. Very, very fun. A good sort of, I think, a good way to learn. It's difficult for people to find parts to hone their skills, to learn different CAD systems. Measuring large objects around the house isn't always easy, but Lego is quite accessible. And Discord is working. I can see someone has joined the server. Welcome, Ditzy. Hopefully you find what you need there, but if not, let me know. So that part, it's done. So we're up to step 7. So we're putting on another black piece at the back and another one of those joiners. So this is the point where we start to use the mirror component. So I'm not just going to add like another one of these components over here. I'm going to save time. I'm going to select the right plane. I'm going to press the mirror component. And I'm just going to go through and pick the components that I'm going to mirror. It's very obviously these ones here, pin that's underneath it, this gray one, this yellow one, We might not be up to all those steps, all right, but they're coming. So I'll just get a few of those in. I'm not going to do these 2 yellow ones yet. They will come later. I'm going to press next. We can see the preview as well. So the purple and yellow ones here are the ones that are getting mirrored. I don't need to do anything fancy with these settings for this example. I think everything works out. You press the tick. You can see there. We just saved a bunch of time. Now we'll come back and edit that mirror component later as we add more components to it. We don't need to do multiple mirrors. If we're using the same mirror plane, we can just edit that one over and over to put more parts into it. So that's step 7. Step 8, we've just done with the mirror, so we don't have to worry about that. Step 9, well, here we go. We're putting one of those yellow pieces on, and then it's getting more complex. So I'll put that one in the mirror. I'm going to edit the mirror component. Just going to select that inside one, press OK, and you can see that's across there now. All right, I'm going to hide the right plane. Don't need that anymore. And now we have a bit of a more complicated sub-assembly to put together. So we're starting to do these gear components. We're going to start with this. We're up to step 10. So to do this, one thing I'm going to do is I want to rotate this part, and I want to rotate it so that it is facing up. So I'm just going to grab these 2 faces, press mate. But in the mate tool here, over on the side, there's an option to just use the positioning only. If I press the tick, that means it's going to rotate the position of that part, but it's not going to add a mate to it. So I'll go to the right spot now. I'm going to temporarily fix this part. And that means this one, you can see the little F next to it in the feature tree. This one can't move, but it makes it easier to do some mates to this part, other parts, like this grey one here. So I'm going to go out, I'm going to need a few of these. I'm going to grab a duplicate. I'm going to use the mate tool and get this concentric. I'm not going to make this one lock rotation because this is one that will spin later. And I'm going to use these faces to fully define that one. Well, sorry, to locate it. So you can see here, it can spin. All right, next step. Now we're going to put on 2 yellows on the outside and the worm gear. So the 2 small yellow pieces are over here. We get those 2 in, and then the worm gear, bring that across. Okay, so I'm going to mate, and same thing. These are rounded crosses. So I can use a concentric mate, and then I can use a coincident or parallel mate to line up the faces. In this case, these yellow small parts go all the way into that inner position. You don't have to do the mates in the same order. So this one I can do coincident first, concentric second, and then if it's rotating, I can do the last one parallel or coincident last. Now the worm gear is just like anything else. It's got a concentric face going through it. I can drop it right down to the bottom here, and then to get it to rotate correctly, I need to do and mate for these 2 faces. And then later, once we fix, let's say, this part, we'll find out this one will now rotate. Right now, this one's rotating. This one's fixed. Let me change it. So I can make this one fixed, this one float, and now this can rotate. Cool. Save. Keep going. Next step. All right, we've got this thing to build. So we've got another grey one in the middle. So this one here, I've got 2 of the grey axles, 2 of the yellow round parts, 2 of the yellow longer parts. So I need to get 2 axles, need to get one of these, 2 of these, another 2 of these. I'm just holding the control key down when I click and drag. How does it go together? We have this one on the outside. I'm going to temporarily fix this as well. I'm going to grab this face and this face for concentric, this one and this one coincident. I want to rotate this up. I'll get that face, and that's going to line it up. Cool. Awasme, I notice you are making the physical parts more than aligning the axis or planes. Why? It's easier. I'll use the planes when I'm trying to get something symmetrical, like in the middle of my assembly. I find it easier to select like a round face than it is to select an axis. Like I can view temporary axis here. You can see these very fake blue lines, but I prefer to use the face. You could do either. In most situations, either one will be perfectly fine. Good question. Hey guys, just want to interrupt for 30 seconds. If you're watching at this point, you're obviously taking your SolidWorks training pretty seriously. I really like to recommend my one and only paid course, which is currently on Udemy. It's called SolidWorks for Designers, Foundations to CSWA. And that's going to give you all the basics you need to achieve that certificate level and move on further with your SolidWorks training. I go through each of the features listed on the CSWA exam one by one. I also cover elements such as design intent. There's some example projects thrown in, as well as other resources to help you with your learning. The course is really fresh. I only released it earlier in 2025. If you'd like to give it a go, please follow the links in the description. Thanks. We'll get back to the content now.
So next, I only needed one of these, so I can delete one. This one, I'm going to do the same thing I just did. Concentric, parallel, or coincident. I'm going to get a couple of these yellow pieces in. Same thing, concentric, coincident. Same for this one, concentric, coincident. I want to make sure that they're lined up properly. This last one will be a bit tricky, I think. It's rotating, but I can see that face in there is not quite straight, that one. Okay, all right, and then let's put this one on the other side. Same thing. Okay, now we can see clearly here there's something wrong with our dimensions. We'll address that later. Now, where does that part sit? That drops on top. It's a bit blurry here, but I'm going to load this one, bring it over, make this to this, and just bring it up high enough so it's over the top. And then I think the gear sits on top of it after that. So I'm going to grab one of these gears. Let's use this one. I'm going to make those concentric. And then this gear is going to sit on this face. And then I'm just going to make sure inside that they are also lining up. All right. So we can see it turning. And I think now, no, we can't quite put it on yet. We've got to put this black one on. So it is becoming quite a bit of a little sub-assembly. So we get a black skinny one. And this is one part that I didn't have in the assembly earlier. So that's a bit of a mistake. It's okay. I've got it here. It says yellow. It says black, but it looks yellow. Is black. There we go. And this yellow one I think I need. Yeah. So I'm going to mate this one, make this face. I'm going to rotate that down. I think the next one sits on this. Yeah. All right. Oh, is that too high? Yeah, that's the wrong hole. Selected the wrong hole to mate to. Needs to be this one on this one. That. And this is why I didn't mate this before. This part here actually can move up and down ever so slightly. You'll see that in a minute. I'll actually change that mate once I've done this next step. So I don't want the edge, I want the face, and then I want to have this not rotate. Cool. And then it's got that black part going through the middle. It's over here. So I'm going to grab that, like that. Concentric, it's coincident. That's one that can be lock rotation as well. Right. Then it has another black piece on the other side, and then one yellow one. Grab another black. Now I can make concentric like this on the outside as well. That works. Coincident and concentric. And yep, we can see some of the fitting issues. So it's probably a good time to deal with them right now before everything starts getting hidden into the assembly. We can see it's got the yellow outside piece there. I might just do that in a minute. Right, so let's just have a look at what's not fitting on this. So first up, this black one. I'm going to save the assembly and I'm going to edit this one. And I can see the width of that is 15.8, which from experience, I know that that's right. I'm happy with that. We can also now do a more accurate measurements because I have better calipers. So let me show you this. All right. And the parts in question. So this one here. Now in our CAD, just going to isolate the part for a second and going to edit the part. And we can see we gave it a width of 4 millimeters. So from this face, 4, what is it actually? So these calipers are much more accurate than what we'd used previously. Its actual width is 3.95. Not bad. Okay, so I'm going to change this to 3.95. Might be a bit smaller. Everything else can stay the same. Exit isolate and then save. Let's check that grey part. This one. Well, there's this one. To make sure I've got the width right here. So go here, measure 7.85. If we have a look at the width of this, what are we getting? 7.8. Okay, that's close enough. Right. These yellow ones, see the width of these, 3.97, just under 4 millimeters. If they are 4 millimeters, they can stay as that. 3.9, that's interesting. 3.93. There's a bit of variation as you'd expect. If I put two of them side by side, 7.9. probably 3.95. I'm measuring the physical pieces because this is how I modeled all of the pieces from measuring them one by one. So this whole project, everything that you can see here, I have modeled from scratch. These are not downloaded from some existing library. These are parts that I have modeled one by one, as you can see here. So all the dimensions are dimensions that I have taken. And when I did these parts, I had a crappy pair of calipers at the time, so they may not have been as accurate as I can see now. For instance, this 23.4 rather than 23.2. But I want to make sure that those holes, they should be 8 millimeters apart. I might reverse that. We want to make sure our assembly fits together too, so that's pretty important. What it can mean in this example, like if we look at this black piece here, this one is 15.85. I'd say it's 15.8. What did I model it as? 15.8. That's fine. All right. So perhaps I just need to add a bit of clearance in here. So this, let's say from like this face to this face, should be another 0.1 further. So I can look at the mate that's there and I can say, okay, there might be a 0.1 millimeter space and there might be a 0.1 millimeter space on this one. All right. Once I've done that, these two as well, say maybe they're going to sit on the outside faces. So they've got a little bit of clearance. And now this one fits. I don't have that interference like I did before. It does look bigger though, doesn't it? So see this black one's 3.6 radius of that part here. Right? So it's actually 3.7, right? So if I open up that part and have a look at how it's built, I can change that, 3.7. I can update the width, remembering that the hole spacing needs to be 40. The hole spacing needs to be 8 millimeter. So we're at 7.95. Can't have that, 8. And this black one, I have that as 7.8 mil. That's correct. All right. So there's a little bit of difference in size. And that would be the next step of this project. Like as you assemble things, you can see how they fit. So you can see where there's clearances or interferences and how accurate you are. And you can make adjustments to your model. That all looks good now. We'll do interference detection later. Let's keep going and put more of it together. Yep, it was a lot of work. But for this project, to do all the parts you see here, only took us about 10 hours through 5 different streams. So it was pretty quick. Pleasure. See you next time. Okay, so we've got to put this on now. We can see it kind of flips around. Black pieces are facing the front. Now, there's everything here. Is anything fully defined? Locked in. So is anything fixed? Yes, this one is. So I'm going to float that one and I'm going to rotate it around like this. Now, some parts might, as we're moving the assembly, some parts might like get out of position, right? That's fine. We'll just bring them back in when we're ready. So how does this sit? We can see the top ones joined together with, there's the gray one, this one. This one comes through the top and it's going to match at that end. So I'm going to go mate. I'm going to hit this face and this face brings it almost in. And then this face and this face. And then a coincident, concentric mate, parallel mate. That is now all in position. I'll just slide that one through. You can see this now. This will rotate as I move my cursor around in the circle. And there's no interference that I can see. So that's pretty good. All right. Next steps. There's a yellow one on both sides. So I'm going to edit my mirror component. And I'm just going to click in that yellow one. So I've got one on both sides. And then that's everything on this first page. So right to page 2 of the instructions. All right, so we've got an L shape and a couple of pieces being attached to it. The L one is here. We also have a small one of those and a yellow one of those pieces like that. I'm going to mate those pieces first. So mate the concentric ones, lock rotation, do a coincident face, those two, and then for the axle, that's going to come through this hole. I'm going to line up those faces. That doesn't want to mate that one. Might have to play around with that. Let's just see where that piece goes. It's going to put it in the right way. I think that hole is going through there. So this piece is coming over here. I believe this is going to drop through the second bottom hole, and these faces will be coincident. And then rotate that around, and I can see that this one, these two are going to line up, and this yellow one's going to go all the way through like that. So I can make that coincident. It's fully defined. Okay, cool. Now we're putting on just another one of those long pins on the back. So I think that one comes over here. So that's a concentric mate, lock rotation, and the outside face will match. Looking good. All right, now we've got this front sub-assembly to do. We are getting there. So this has another one of those grey parts. We have one of the blue ones. I actually have two of these gears, two of these axle pin connector hubs. And then got this black one comes into it as well. All right. So I'm going to just want to rotate this one a little bit. That'll do. And I'm going to fix that temporarily. I'm going to put one of these through, and then these are going to be coincident, and then this is going to run through the middle of that. Now these two are going to be parallel, so I can use those faces to make them parallel. And then this black one fits on the end. It has a concentric mate, and I want to get it, this face and this face going to be parallel. Something's happened there. It's not rotating properly. So I'm going to break other mates, and then whatever the broken mate is, there's nothing that's broken. I don't know why I didn't want to rotate there. If there was a broken mate, I could just delete it because I didn't need it. But this next one, I just make this and this coincident. All right. Now we're going to put that L-shaped one of these on the side. So the blue one sits in the third hole. So this one sits in the middle. Flip that direction. Get those two to be concentric. Doesn't want to do it. Does want to do it. Got to remove that parallel mate because those two should be, I should be able to make these concentric. All right, something's not quite right. I think it's that these two are coincident. I'm just going to delete that mate. That lets these two create a little gap there, and that lets this one be concentric with this, that's fine. It's fine to do that. So that's all done. Then I'm going to put a long yellow one through the top with another one of these gears. So this is running through this position. I want to make sure that they're lined up. And then that's going to have this gear around the middle of it. Again, get these faces parallel. And the gear is going to sit right in the middle. So I'm not made it to the right plane yet. What I'm going to do is use the front plane of that part, or it's plane one of that part, and what will be the front plane of the gear to get them coincident. That way that gear stays in the middle. You can see it's got another one on the other side, which I'll use with the mirror tool in a minute, and then we can connect it. So I'm going to get the yellow one to go through that L shape. So I can now float the one that's fixed, bring this over here, mate this axle to this hole, and then this, I'm going to get the plane one to go in line with the right plane. Now I've just got to move some things over, but you can see most of the mates actually in the right spot. Right, this needs a coincident mate. How's that looking now? I can do this up and down, so we get movement. And to finish it off, I don't need to add in a lot of extra parts. I can just update my mirror component. I'm going to include this one and this one. You can see that closes off those two sides. I do also need to include this little Technic pin. Yeah. And then this yellow one. So this will be coincident on the end face, right? And that is looking really good now. We're on a home stretch. So we've been through all that step 12. Step 13, now we can connect the bucket. So that's this one here, big one. How we're going to do this is there is a round face here on the bottom. And at the very center of this is another round face. So we're going to get them concentric. And then for this bucket, I'm just going to move it into the middle and find will be the right plane over each, mate them. And now that bucket is mated, but can still rotate, which is fine for now. The last steps, I'm going to mirror the other side, which we've already done, and then put on the wheels. So we don't need any more of these parts, I don't think. You can see our wheel is over here. We do need to mirror that pin, all right? And then our wheel, we're going to do two of these. So we're going to get first the wheel hub. Hey, Rock Flora, you're welcome, mate. I hope they work for you. Let me know how you go. I'm going to grab these two faces, make them concentric, pull that across. I'm going to use this face to be coincident on the inside. And then with my tire, get that concentric. I can get the tire and the wheel to lock rotation, and then this face to the outside face. This way my tires can still rotate. Okay. Now we're going to mirror that, but we'll have to do another one at front as well. So I'm just going to put that in first. So concentric, but locked, coincident, and coincident. Now, the wheels don't rotate at the same time. If we make them both, we choose like the top plane of the other one. We got wheel top and wheel top. You can make them parallel. Then when they rotate, they'll rotate together. And now we can do a mirror component. I'm just going to grab all 4 of those. And there we go. Assembly is done. We can save, front view, isometric view, just as we planned. So pretty happy with that. Yeah, now it's time to check for some interferences and fitting issues. I think before we try and do anything with the gears. How'd you go? Anyone following along? Heck, I don't know if you're still there, but curious if anyone's got this open. Had any chance to get through it. All right, let's first, I'm just going to do a couple of other mates. Do a parallel mate for this one. I'm also going to, remember that very first part? We mated it to the top plane here. Delete that, because what we want to get is that top plane. See there? We want to get that as our like ground. So these wheels are 23.6 in diameter. So if I move this part up half that dimension by getting the front plane and the top plane mates distance, 23.6 divided by 2, that should put it in the exact place that I want. See that front plane now, or that top plane? It's running right where our wheels should be. Take time, Clara. I was asking more so for anyone that started assembling when I started today, but yeah, check it out sometime. Those files in the Google Drive, see if they work for you. All right, before we do much interference detection, I want to clean up our assembly a little bit because we've got a lot of stuff going on here. Couple of ways I want to do that. I want to move all the mechanism stuff into a folder. Mechanism, and the wheels as well. There's only 4 wheels. I thought maybe all the Technic pins could go into a folder. Basically, I'm just looking at ways to organize this a bit more. And I don't want to do it by steps. So I figure by just naming a few parts, that'll help us clean things out. Technic pins, maybe lift arms would be a good one as well. What else for the mechanism? So all of this stuff, that needs to go in mechanism. Put mechanism at the top, Technic pins at the bottom. This one to the mech. This one's the mech also. This gear, this one. Alright, so if I select that, and we'll have this one in there as well. That's most of it. Cool. Thank you. Right, that's neat. Just put all the lift arms in a folder as well. Lift arm. Anything that says lift arm is going to go in there. This is completely optional. You don't have to do any of this. This is just me trying to neaten up the assembly, and now I've frozen. Yeah, I find that I've got a new laptop, and I feel like I get occasional random SolidWorks graphics issues, like this example right now, where it's just frozen on a drag of a part in an assembly. It's not great. So I'm very regularly saving. Of course, the computer's not frozen. It's just this. I can save, but I can't quite get past that step. Rotate. Okay, good. We're out of it. That's a relief. All right. Cool. So let's do some interference detection. Hey, thanks for watching all the way to the end. Really appreciate that. This has been the LEGO Build and Learn series by Fully Defined. If the next video has been released, it'll be on the top link to your right. Please hit the thumbs up and subscribe, and leave a comment below with what you'd like to see next. Your feedback is what motivates me to provide more content. See you in the next one.